Welcome to Joey's Dynamic Programming tutorial. In this video of Joey's Tech, you are going to learn one very interesting dynamic programming problem, which is count sorted vowel strings. This dynamic programming example problem is from the word of strings, and I have taken it from the website of Leetcode. Count sorted vowel strings can be one of the next dynamic programming interview questions for you, and thus understanding it completely is necessary. And to understand it completely, all you have to do is watch this video till the end. I have tried to keep the explanation as simple as possible, so I'm certain that you are going to enjoy learning it. Let's check out its problem statement now. Given an integer n, you need to find out the number of strings that can be formed only with the vowels of length n. Yes, the vowels, which are a, e, I, o and u. The strings should be lexicographically sorted. By lexicographically, I mean that the strings should have vowels in the same order format as they appear in the dictionary. Below are a few examples of strings that are lexicographically sorted. They are AA, AE and IU. To clarify further, the strings that are not lexicographically sorted are IA and EA. We will find out the number of strings for n equals to 2 that can be formed only with vowels, of course, which are lexicographically sorted. We'll solve it using our favorite dynamic programming approach, but before that, I want you to subscribe to my channel and press the bell icon that is next to it, because that way you will get notified whenever I release new videos on my channel. Before we begin, let us brainstorm a little. When n is equal to 1, how many strings can we form using the vowels? That means, how many strings of length 1 can we form using the vowels? I say 5. Do you agree? I'm sure you will, because there are 5 vowels and each one of them is a string in itself of length 1. Now, one thing that we can figure out using these strings of length 1 is that the count of strings starting with A of length 2 is equal to the count of strings of length 1 greater than or equal to A, which is 5. These strings are AE, AI, AO, AU and AA. We can also deduce that the count of strings starting with E of length 2 is equal to the count of strings of length 1 greater than or equal to E, which is 4. They are EI, EO, EU and EE. Remember, they are lexicographically sorted, hence there can't be any string like EA. On similar lines, the count of strings of length 2 starting with IOU will be 3, 2 and 1. And the strings are written over here. You can check. Just like there are 5 strings of length 2 beginning with A, there are 5 strings of length 2 ending with U, right? Similarly, there are 4 strings of length 2 ending with O. All of them I infer from strings of length 1, which are nothing but vowels. We will use this logic to find the answer and construct our dynamic programming algorithm. This can be one of your next dynamic programming interview questions, and I hope that you are watching it closely. There are 2 pillars of this problem. 1, the length of the string, which is n, and 2, the 5 vowels. Hence, we will create a matrix whose rows will be represented by n, that is the length, which is 2, and columns will represent by the vowels. The algorithm will use the 0th row and the 0th column, hence the matrix dimensions will be 3 by 6, that is 3 rows and 6 columns. I will fill the first row and column with zeros immediately. Now we arrive to fill the value of this cell represented by index 1, 1. By common sense, we will fill 1 in this cell because at this subproblem we only have A and the length is 1. This means there is just one string, hence 1. On similar lines, I'll put 2 in the subsequent cell because now I have A and E in my sub problem. So for length equals to 1, we get 2 strings. Let's now fill 3, 4 and 5 in the subsequent cells. We move to the second row now. Length is 2, but the string, that is the vowel, is 1. Think what should be the value here? It will be 1. But what string will this 1 represent? It will be double A. Like I told you moments ago when we were brainstorming that to calculate the number of strings of length 2, the count of strings of length 1 will help. So we are deriving this number 1, we are taking this number 1 from the top. This represents all strings ending with A, just like I said before. We move to the next cell now in the same row. I know that you are thinking right now that we will derive the value from the top because that represents 2 strings ending with E, which are AE and double E. Yes, you are thinking it correctly. However, there is one more component of the solution which is in this cell, the value of which is 1. This represents double A, which we calculated moments ago. So 2 plus 1 gives me 3, which I will populate in this cell. The strings will be double A, AE and double E. Let's move to the next cell. The value which gets populated here will be the result of 3 from the cell above and 3 from the cell on the left. So what we get from the top are AI, EI and double I. And from the left we get these 3. Overall there are 6 strings of length 2 when we have just 3 vowels. Based on this concept, what will be the value in this cell? It will be 6 plus 4, which gives us 10. And the value of the last cell will be 5 plus 10, that results in 15. This last cell gives us the number of strings lexicographically sorted of length 2 when we are given these 5 vowels. You will find the GitHub link to the Java solution of the count sorted vowel strings problem from Leetcode in the description box below. This concludes this video. Let me know how you are finding the series of Leetcode problems and solutions in Joey's dynamic programming tutorial. Any questions you have regarding this TP problem, let me know in the comment section, and if you liked the explanation then subscribe, like and share this video. Until the next video, bye bye.